This video goes through the time series GAN functionality in the investment simulation module. So here, when you go to the examples and then investment simulation, you can see that example number 6. It's called time series GAN, and this is the one that we'll be going through today. So basically, these generative adversarial networks for time series investment market simulation, it's something which is in its very early days, and this is also something that I introduce here in the portfolio construction risk management book. So if you go to the Substack post where you can find the latest version of the book, and then just download it and go to this generative adversarial section, then there's an explanation of the history of these GANs and the essence of what they are trying to do. So basically, you can imagine that we have two different neural networks. One that we call a generator and another one that we call a discriminator. The idea is then that we feed some normally distributed noise to the generator, which will try to generate data that looks like what we have seen historically, and then the discriminator will then see if it can discriminate between the synthetic data that we generate and the real data. And the idea is that we want to be able to generate data which the discriminator cannot see the difference between the real data or the synthetic data, and then we know that we have a good model so that we can use this generator to generate new synthetic samples in the same way that we do with resampling and we do with variational autoencoders. So all of this, it sounds nice in theory, and also for many applications it actually works like this, but it requires a lot of careful training engineering, and it becomes even more complex than for the variational autoencoders. And when we have these tabular time series, the implementation is just really hard. So the idea for these time series GANs and the architecture that we have been inspired by comes from this time series generative adversarial networks article. So basically here they explain some of the challenges of just using GANs that do not handle time series data, and also say that we want to be able to capture both the cross-section and the time series dependencies. And of course, this is also what we describe in the portfolio construction and risk management book. So here I will just scroll down to give you a visual illustration of how the architecture actually looks in this article. So what you can imagine is that they essentially combine an autoencoder. So first they take the raw data and then reduce it to something which has a lower dimension. So this you can think about as like a nonlinear PCA, which you can also see about in the variational autoencoders video. And then when they have these latent variables, then they apply this generator and discriminator to that data. So basically that the dimension is reduced a bit. So one thing that they also introduce here is something that they call a supervisor, and this is basically to be able to capture the time series dependencies in this latent data that we have. However, when we work with these things, we found that if you handle state correctly for all the other elements during training, validation, and simulation, then actually this supervisor doesn't really add anything specific. It's only when you have stateless neural networks that maybe this supervisor can add value. But the point is that in our implementation we keep the model a bit smaller, so that we just focus on training the autoencoder, and then we generate new synthetic data in the latent space. Basically, this is what we found to give the best performance when it comes to ease of training and to avoid overfitting and things like that. So this is something that we will now go and see in the code. So basically here we just import all the packages that we need in this investment simulation module, and then we load the time series data that we've been working with and the stationary transformation. There's some data that we keep for testing using this train test split, and then we start to define the model.